So, what have we seen? We join an online discussion suggesting new ideas. The software analyzes the discussion, and with the output of the previous step, we create a 3D world. We explore it, and we could modify it. Let's have a look at the architecture of Vision. The core is represented by a client whose duties are: retrieve discussions from forums, communicate with the semantic analysis server, create a 3D scene by means of XNA engine. Furthermore, it manages avatars communications and 3D models updates. In order to understand people's language, we need a semantic analyzer. Rather than develop it all by ourselves, we used a standalone application called GATE, General Architecture for Text Engineering. It's a Java open source project continuously developed at the University of Sheffield since 1995. It's a very powerful tool for information extraction purposes. We used it to find in a text entities, features of those entities, and relations between entities. Every extracted information is bound with a specific user. So, like most search engines do, we weighted ideas according to the number of different users expressed to them. For instance, an idea expressed by a lot of users is much more important than the one expressed a lot of times by the same user. In this way, we give more relevance to the community thought. A discussion can be led by a moderator, which participations have a greater weight than the other user's ones. His choices cannot be modified by other users. In this way, the institution that starts the discussion can direct it following needs or environmental constraints. The 3D world gives a lot of opportunities. As we have seen, it is possible to insert, modify, and move objects. The avatars may also communicate one another with an internal chat system. The Vision typical scenarios of employment can be various. For instance, think about a municipality that wants to reshape a city block building a new residential area. Vision can be used by the citizens to express their ideas on how that area should be built. Moreover, they can suggest ideas for the completion of an area partially built. Vision can be used not only to build but also to rebuild. Thinking of areas damaged by natural disaster, Vision allows to rebuild those areas using people's memories. Think, for instance, on what happened in China not a long time ago. Someone could think that Vision is comparable to 3D world simulators like Second Life or Active Worlds. It's not like that. There is a fundamental difference between these systems and Vision. We are not building a virtual world, we want to build a real world using a virtual one. What you've seen is the today version of Vision. The evolution will continue. Indeed, we've planned a further development map in order to integrate more functionalities. The first one is the integration with Microsoft Virtual Earth. Within a discussion, it will be possible to contextualize the area we are talking about using Virtual Earth maps. Afterwards, the entire Virtual Earth community will be able to see the 3D scene we've built in that specific area. The second functionality is about the integration of Vision with professional 3D modeling software. So, Vision wouldn't be used only by citizens, but also by professional figures like environment designers. We would thank Microsoft for the organization of this contest, Professor Paola Rizzi for her support to our project, and the City of Paris for hosting this year's Imaging Cup finals. And we would also show you that without listening to the community point of view, very bad things can happen. In the end, we would like to remember what Sylvie Rimbert, a well-known French geographer, said in one of her publications. La ville apparaît beaucoup plus faite d'idées que de briques, which means the city seems made more by ideas rather than bricks. We have finished and we are ready to answer to your questions.